Today, we are fortunate to have some time with Rachel Clements. She is the Commercial Innovation Manager for International Space Station and also CASIS, which is also known as Center for the Advancement of Science in Space. Thank you, Rachel, for spending some time with us so that our audience for 3D Heals 2020 can get to know you a little bit more before the event. So I looked through your CV, and you have done a lot, and you're by most a scientist to start off, and now you're working with ISS with various commercialization projects. Very impressive and very relevant to the current state of related to COVID and what science can do. But I think people will be interested to know the earlier career, how you became from a scientist, then become a NASA scientist, and then eventually moving on to where you are today.
So I started, let's see, I got really interested in marine biology. It's kind of where I got super interested in biology in general. And then as I went through my academic career, I moved into more of a focus on just general biology. And when I went to graduate school, I actually studied the mechanotransduction apparatus in the inner ear. We used a model organism, the zebrafish, to study that process. After graduate school, I finished graduate school in 2013 and was fortunate enough to land a position as a research scientist at NASA Ames Research Center. And there I studied a bunch of different things, but my main focus was on the host immune, the host immune and the pathogen interaction in the spaceflight context. So what's really interesting about spaceflight, and it was, when I started that job, I learned a lot about space and how space impacts the body and every other living thing that ends up going up to space. And so it was a real paradigm shift in how I looked at science. So it was a really great opportunity to learn something that I felt like I understood really well, and then you put it in this whole other context and it just opens up all these other questions. So and then from there I ended up deciding to make a switch away from doing basic research into a more business context, just based on my own personality and some of my interests. I was much more suited to something like that. So when I found out that CASIS was hiring, I jumped at the chance, and I had a friend that worked there, so I had an in. But anyway, so I've been with CASIS for ISS National Lab for about 2.5 years now, and it's been a fantastic opportunity for me.
Yeah, I think we met perhaps when you just joined CASIS, right? It was a couple years ago. And I actually think it's important to have individuals like you who are great communicators to be the bridge between deep science and applications in the commercial world, because a lot of times people don't know what we're doing with ISS. It just seems like outer space, no pun intended. Since we're on that subject, and I really like in your written interview, you were saying that you had a paradigm shift of now you're thinking. It's a thought experiment to think about what it's like to be 0G and what it's like to be where we are on Earth, why we are today. So you want to just explain to our audience a little bit on why microgravity and what ISS are doing is so important to the future of science?
Yeah, so first of all, it is not a platform that we have access to on the ground. 1G on the Earth, there's, it's sort of fiction. I've seen some movies where they have these, anti-gravity chambers. That doesn't actually exist. So there are very few places where you can access microgravity. The way I start to explain to people about what microgravity does to science, I start really fundamental. And if you think about, if you're drinking like a glass of water, right, you look at that water and there's a lot of different forces that are being applied to that water in that glass. And 90% of that force is gravity, right? Of the phenomenon that you see in the water, that's all due to gravity, like sedimentation and convection and buoyancy. Those are all gravity dependent phenomena. So when you remove gravity, that 10% that's left becomes everything. So you find that surface tension and viscosity really dominate, and some other interesting observations. So if you ever feel like maybe your viewers will be interested to just go on YouTube and check out videos of astronauts playing with water, dropping Alka-Seltzer tablets in there, and these endless hours of fun, and some good explanations too about what happens. So that's kind of at a fundamental level. And then if you take that and you think about the fundamental physics, and then apply that to any kind of system, a materials or a biological system, and you see a lot of changes happen.
Absolutely. And I also want to say thank you, Rachel, for contributing to our Expert Corner blog recently. It's actually a pretty dense article. I have to read it several times to really understand all the new terms that's related to microgravity. So I'm going to warn all the readers ahead of the time. And also, I am going through your written interview, which is also probably going to be a lot denser than this audio or video interview. So very fascinating world. Now, the majority of our audience is very much interested in how to reinvent healthcare using 3D printing and biofabrication and bioprinting. And you actually went in length about why microgravity or whatever ISS projects are relevant to this branch of science. Could you elaborate on that a little bit more?
Sure. I think in terms of, I'll just start with biofabrication, which is kind of the thing that I think about the most, so it's easiest for me. So if you think about a structure you want to print, especially in a biological context, those scaffolds or some of the materials that you use to build these structures, they have to be able to stand up to gravity once you print them, right? Until you can seed them with cells or whatever the process after that is going to be. But the density of that material or the thickness of that material, the viscosity level, isn't necessarily always conducive to cell growth or the physiology of the thing you're trying to print. So if you were able to take gravity away from that context, I think there's a lot of potential to explore different kinds of materials that you could print, maybe some lower viscosity materials, or maybe some fine structures that would be difficult to print in a 1G environment. And yeah, I'll just kind of stop there.
So have we successful bioprinted at all, or are we able to do anything at all related to bioprinting so far on the station?
Yes, actually there is some capability. The Russians were actually the first to do it. This was a couple years ago. I can't remember exactly the year, but it was pretty recent. They sent, I think it was an Argonaut. They sent that up there. It's a magnetic 3D printer. And then for a US company, TechShot, which is a traditional spaceflight hardware provider, partnered with Enscript, and they built this 3D bioprinter that can print cells, not just biomaterials, but can print cells. And then there's another chamber within that piece of hardware where you can incubate cells. And they have run a couple tests. They ran their validation experiment at the end of last year. And SpaceX just sent another rocket up in March. I think it's already come back a couple weeks ago. But TechShot sent another round of experiments up there to iterate on what they had learned from the previous experiment. And as far as I know, that facility is available for people to use. So,
are there any already available publications from these experiments yet?
not yet, none that I have seen. But I hope there's some in the work, at least some level of communication about what's going on. TechShot has sort of shared some of the early lessons, but I think it takes maybe an academic partner to really take it to that sort of scientific level publication. So we're looking forward to facilitating more of that. And
yeah, I'm looking forward to it too.
Yeah.
So I mean, I think in your written interview, which we will publish very soon, we were talking about the challenges of running these experiments or even setting up a facility for biofabrication and bioprinting. One is probably cost. So the question is, how do people get enough funding to do experiment with the station? And the other is crew, which you said there's some kind of late progress on that front, that we're going to have more crew members on the station to manage these facilities.
Yeah, so there's some really fundamental issues with any hardware facility. It's not necessarily unique to a 3D printer or bioprinter up on station. But aside from the cost, there is, because you mentioned crew time, so I'm just thinking on that. There is limited space, literally, pun not intended, for shipping these pieces of hardware. So sometimes for certain bits of hardware, they are traditionally quite large. They might be like a benchtop item, so it would take up a fair amount of space on your bench. We, at the ISS, there isn't that kind of space available. The configuration of the space is also different. So everything is a wall. There's slots to put things in, and those slots have specific sizes. So hardware providers have to work within that. Also, in a lab, you have access to expertise, right? A person who spent their life studying how to print collagen into a matrix, or and then cells subsequently after that. And the astronauts are generalists, so they're very good, and we work, and the hardware providers work very closely with them to ensure mission success. But it's always beneficial for something to be as automated as possible, where they can just press start. It is, getting back to the cost thing, it is a lot of work to build these things, because you're taking an existing bioprinter and you're reconfiguring it such that it can function in microgravity, and that it can fit within the space, and it fits within certain power requirements. So it takes a lot of engineering know-how to do that. And so I think with the example of TechShot, there were a bunch of different sponsors. The ISS National Lab was one of them, to help build this facility. So yeah, it is a factor.
So obviously, ISS has a business case for companies to pay for a spot or doing experiment with ISS. Have you seen any potentially commercially successful products coming out of the ISS projects? I think you talked about Lambda Vision or something along that line.
Yeah.
You don't want to share with us?
So Lambda Vision is a great story. I think we're all very, very happy with that success. We have a partnership with Boeing and Mass Challenge out of Boston. It's been years running, and every cohort that comes in every year, we partner with them, and in collaboration with Boeing, we have a kind of a prize that we'll put toward projects from maybe a couple of these startups. And Lambda Vision was one of those companies. A few years ago, a couple years ago, they won and were awarded a flight project. So they have this retinal implant that's intended to treat retinitis pigmentosa, is their main focus. And the device, or not device, but the implant is several layers of different proteins, right? And the retina is a highly ordered structure, right? So one of the issues that they faced was sedimentation, right? A gravity dependent phenomenon, in how gravity was impacting the, after they deposited these layers, how long they could wait until they deposited the next layer, right? Because they had to make sure that everything was in place, and reduce the risk of mixing of these layers. So they thought they could accelerate the process by sending it into the ISS. And they conducted that study a few years ago, a couple of years after they were awarded the flight project, and have very recently, I think last month, they were awarded a $5 million not prize, but they were given $5 million by NASA to further their study and manufacturing these implants in space. So
yeah, that's incredible. I mean, given how little funding we have these days from research, that's pretty remarkable. But I look forward to more of your presentation at the conference. I know you're going to go in depth on the more technical aspect on how to work with ISS. But let's talk about something fun. In your interview, you said you haven't seen a rocket launch so far throughout your career.
Not until March. Yeah, I started working at NASA in 2013, and we're coming up on 7 years of me working in space. And even though I worked on flight projects, I was never in a position where it was necessary for me to go to a launch. I was always involved in the post-flight analysis, so all the pre-flight stuff the engineers were focused on. So so when the opportunity presented itself, we've been doing these events around launches this past year, and so I went and supported one of those events, and it was incredible. I don't know, have you ever seen a rocket launch?
No, my imagination is a bunch of scientists sit around computers and clap after it's launched. That's what my thinking is. That's from the movies. What is it like? I mean, why is this so impressive? I mean, other than the concept of it.
I think for me it was so I wasn't at Mission Control. We were in this event space that was in the top floor of this building at Kennedy. So it was, there were snacks and a bar and everything. And a lot of the people there were, they had projects that were on the rocket to go up. And so, I mean, the launch was spectacular. The fire, it was also at night. So it was really cool to see. And then the sound, when it would break the sound barrier, it was minutes later, because we were viewing it for obvious reasons from a very far distance. But I think for me, the best part was seeing all of these researchers it's not a small feat to plan for one of these launches. There aren't that many a year. And there's a lot of work that goes into getting ready for a launch. And here they were, seeing their research go into space. And I mean, there were tears, and there was like a group of high school students that were just beside themselves with excitement. So that was really adorable. But some of the partners that I had worked with on their projects were just so excited. And it really, it was like one of those moments where you think, yes, this is why I do this, is for these moments,
Yeah, well, that is the party I want to go to in my lifetime. It sounds like fantastic time.
Open invitation.
Okay, I'll take it. I mean, it sounds like a milestone, witnessing a milestone. It could be a large or small milestone in humanity. Another follow-up question to that is, I know you're like a super athlete. You do this AIDS fundraise cycling for every year for the AIDS Foundation from San Francisco all the way to LA. So any chance of you ever going to be in the space?
I wouldn't say I've never thought about it. But I think that ship may have sailed for me. Plus, I've had a couple knee surgeries. I'm not sure, how that would go over.
But you don't need a knee in the space. There's no gravity anymore.
Well, I have to be able to maintain bone density, so I've already got some holes drilled, So, yeah, but you know what? If I was given the opportunity, I would absolutely go. They're starting these commercial crew launches, so I think right now I'm just saving up for one of those seats.
And you never know, medicine is also advancing.
Mm-hmm.
And maybe we should do more experiments on ISS so that we can advance to a point where you can go on to the space station.
Yeah, actually, I think the recent study that was done with that 3D bioprinter was on a meniscus. So it's in the works.
You go. Yeah. Well, Rachel, thank you so much for this interview, and thanks for taking time to write for us and talk to us. And I look forward to your presentation in June.
I look forward to being a part of it. Thanks for this opportunity.
Thanks.